What's the matter? What's the matter? Guys, what's the matter? What's the matter? Come on. You don't know what the matter is? Well, I know what the matter is. Matter is what takes up space. And being that we have been learning about classifying objects through properties of matter, we're going to talk about exactly what matter is. Matter is one of the classifications that we go over. And even though we've only briefly talked about it as you looked through your vocabulary, today I'm going to show you what is the matter. So before we even begin, Cubone, what do they need for today? They need to print out their experiment notes page. You're very right. But what about if they don't have the experiment notes page? Oh, they should because it's attached to the assignment. Yeah, I forgot about that. I did do that. What about if they can't print, though? What can they do, Cubone? Oh, they can get a piece of notebook paper and write down all of the information. They can write down the title, what they see, and the materials. Very helpful, Cubone. Thank you. All right, my friends. So before we even begin, please, please, please make sure you have your experiment notes printed off. I know you can only see half of it, but I put it there for your reminder. So make sure those are printed off, or you have a piece of paper and a pencil, because you are turning in the notes to me today after we are finished. And I'm asking you a couple questions in between just to make sure you're paying attention. So why do I have 4 cups of water with black lines on them? Well, my friends, this is going to help me with telling you guys what's the matter. Now, we know that matter is something that, depending on its size, takes up space. So I have 4 items here for you, 3 of them roughly the same size and weight, and we're going to determine what's the matter. So first, we have the pencil sharpener. Now, on the last video, we classified the pencil sharpener. We talked about how it's a solid, it has a hard texture, it's not flexible, it's not soluble. So if I put it into this water, it's not going to dissolve on me. It, let's see, does not have a temperature. It's not hot or cold. What else did we say? Had a brain fart. Well, let's test what the matter is. So what the matter is that depending on the size of an object is how much space it takes up. So by putting this object into the water, I'm going to see how much space it takes up by how far up the water moves compared to the black line. So as you can see, the water is just below the black line, okay? So now if I put the pencil sharpener in here, you can see that the water moved up. We'll see our pencil sharpener is wanting to float a little bit. The water moved just above the black line. So that tells us that the pencil sharpener is taking up a little bit of space. That's what its matter is. It's got a little bit of space. Now, let's look at our little Jenga piece. Do we think that because they're about the same size, maybe not the same weight, that they will do about the same result to the water? Let's see. So let's hold up our water. We can see that the water is just below the black line, and here we go. So it didn't move too much. It did move, but it didn't move too much, and our Jenga piece is going to float as well a little bit. There we go. So I'm going to leave these here for you so you can kind of see it. I know it's a little hard from this angle, but we'll leave it there. All right. Expo marker. Now, the Expo marker is a little bit longer than the Jenga piece. So is this going to produce more matter, or is it going to be about the same? Let's see. Here we go. We can see the water is just below the black line. And, well, it didn't do very much. It did a little bit. If you can see on the side here, it pushes the water up just a little bit. So it does take up a little bit of space. So I'm going to turn them just so you can see where the water is in comparison. There we go. Okay. Now, last but not least, our stapler. Now the stapler is a whole lot bigger than the Expo marker. It's a whole lot bigger than the Jenga piece. And it's also a whole lot bigger than the pencil sharpener. So do we think because it's bigger, it's going to take up more space, or is it going to be about the same as the rest of these pieces? Let's look and find out. Here we go. We can see that the water is just below the black line. And here, let me turn it just a little so you can see that it actually like changes versus the line. There we go. Perfect. Okay, here we go. Boom. Okay, so as you can see, here is the black line and here's where the water ends. So it definitely took up a lot more space than the Expo marker, the block, and the pencil sharpener. So the whole point of doing this with you guys is so that you can see that matter means to take up space. So what I want you guys to think about and make notes on right now is, are there any items around your house? I want you to list 3 items for me. 3 items that are around your house that are like the stapler and would take up more space because it's bigger and because it's got a little bit more weight to it. It would take up more space. It would have a much larger amount of matter. It would take up more space if it was put into a cup of water. Then I want you to list me 3 items around your house that are kind of like the Jenga block. They're smaller and they're a little bit lightweight, and they wouldn't make too much of a difference if you put them into a cup of water like this. See, it barely moves. Barely moves. Okay, so I want you to note those 3 things on your experiment notes. I will be checking for them. If you guys have any questions for me today, please feel free to ask. I will be out there waiting. Now, I will be asking you to turn in your experiment notes, and you will be completing the post-assessment on STEMscopes over properties of matter. So go ahead and do your best. I know you guys got this. I will see you guys later. Say bye, Cubone. Bye, you guys.